All right. Two last rules: product and quotient rules. The product rule says, if there are two functions multiplied by each other, take derivative of the first multiplied by the second plus first function multiplied by derivative of the second function. Okay, derivative of the first times second plus first times derivative of the second. That's the rule for product rule. So the first question, exercise question, x times ln x. The first function is x, second function is ln x. So derivative of the first, derivative of x is 1. Multiplied by second, write as it is, plus first function, which is x, multiplied by derivative of the second function. Derivative of ln x is 1 over x. So x's cancel each other. We are left with ln x plus 1. Next question, an exercise and a mystery question. The first function is x squared, second function is a to the minus x. The derivative of first one, 2x, multiplied by second, a to the minus x, plus first function, x squared, multiplied by derivative of the second function. Derivative of an exponential function is derivative of the power, -1, multiplied by itself. Okay, now I'm done taking derivative. Now I'm going to continue with simplifying. I see x as a common factor and e to the minus x as a common factor. So x e to the minus x is common. What remains? 2 remains from the first term, minus x remains from the second term. So x e to the minus x times 2 minus x is the derivative of this product. Another exercise question. It involves exponential and trigonometric function. So f prime equals, first function is e to the x, second function is sine plus cosine. So derivative of the first, which is itself, times second, plus first times derivative of the second. Let's take derivative of each one by one. Derivative of sine is cosine. Derivative of cosine is minus sine. Now take e to the x out as a common factor. I am done taking derivative. Now simplification starts. E to the x out. Put the remaining inside the other bracket. Sine x plus cosine x plus cosine x minus sine x. Now I see cancellation. Negative sine x is go. So it is e to the x times cosine cosine 2 cosine x. Bring the number in front. 2 e to the x cosine x. Alright. Okay, another nice question is coming. We have natural logarithmic functions. In the angle we have product. It involves radical. There are a lot of things going on here in this function. We apply many rules here. So the first way is taking the derivative by using the derivative of natural logarithmic function, which is derivative of the angle divided by the angle itself. Since the derivative of angle involves product rule and radical, the steps are too much. We have division, equalizing denominator, simplifying. There are a lot of simplification techniques here, so I don't suggest using this way. I'll explain this question in another way. So what other way? So I'm gonna apply logarithm product property. This is one of the things you studied in grade 11. So it says, this property says, if there is ln, let's say a times b, they are both variables, you can rewrite this as ln a plus ln b. Okay, the product in the angle can be rewritten as ln a plus ln b. This is how you separate a and b. So I apply the same property here. I will rewrite this as ln x plus ln square root of x squared minus 1. So remember how to get rid of the square root. I can write this as ln x squared minus 1 to the power of square root, means 1 over 2. Now, we also solved a similar question before. We have a power of angle in the logarithm, so we can bring that power down in front. So we apply power property of logarithm. So it's ln x plus 1 over 2 out in front, ln x squared minus 1. So now I got my function in simplest form. I haven't got the derivative yet. Now I'll start taking the derivative. I got my function in simplest form. Now taking derivative of this is much more easier than taking derivative of that complicated function. So let's start. So take derivative of ln. We have two functions added, so take their derivative one by one. Derivative of ln x is 1 over x plus 1 over 2 stays coefficient. Derivative of ln is derivative of the angle, which is x 2x divided by the same angle. So 2's cancel each other. I have 1 over x plus x over x squared minus 1. Now, I got this as an answer, but I'm afraid I cannot find this in options. I should rewrite this as a single fraction. I have two fractions added, which have different denominators. Let's get the common denominator first, multiplying the first one by x squared minus 1, second one by x, multiplying them by each other. So equals x squared minus 1 plus x squared divided by the common denominator, x times x squared minus 1, which gives us 2x squared minus 1 over x squared minus 1. So I got my answer. So this method for me is much more easier than this method, so it's up to you. So last rule, finally, quotient rule. If there is a division, a function is divided by another function. So take derivative of the top function, multiply it by the bottom, minus top function multiplied by derivative of bottom function, all over bottom function squared. In quotient, we have this plus between them without the denominator. In product, in quotient, we have minus between them and divided by square of the denominator. Okay, let's take a look at the first question, study guide 3. Take derivative of the top. Derivative of x plus 1 is 1, multiplied by bottom, x minus 1, minus top function, x plus 1, multiplied by derivative of bottom, which is also 1, all over derivative of the denominator, x minus 1 squared. Okay, let's simplify this a bit. I'm done taking derivative. X minus 1 minus x minus 1. X's will cancel each other. Minus 1 becomes minus 2 over x minus 1 squared. I'm done. That's the answer. Alright, another common question that you'll face in ministry questions. There are many questions like that, and it's an exercises part. Okay, derivative of top. Derivative of x is 1, multiplied by bottom, square root of x to the fourth plus 1, minus top, which is x, multiplied by derivative of bottom. So it involves radical. Remember how to take derivative of square roots. You take derivative of inside first, which is 4x cubed divided by 2 square root of the same function, all over denominator square. Square of the denominator is x to the fourth plus 1, no more square root. So now this involves simplification. We have different denominators. The first one, denominator of the first one is 1, second one is this. And I can simplify 4 and 2. Now, how do I make them same? I should get the common denominator by multiplying top and bottom of the first one by square root x to the fourth plus 1. So multiply top and bottom by square root x to the fourth plus 1. So it will be x to the fourth plus 1 times x to the fourth plus 1. No more square root. Square rule will be lifted. So just x to the fourth plus 1 remains minus x times x cubed x to the fourth, and we have 2 in front, divided by square root x to the fourth plus 1 all over x to the fourth plus 1. Let me clear this equal to here. It's supposed to be here in front of the big fraction bar. So now I got x to the fourth minus 2x to the fourth minus x to the fourth plus 1 over square root x to the fourth plus 1. Remember, if there is division inside division, there is a top uh, division, the bottom division. You take the top division, multiply it by reciprocal of bottom division. So it's 1 over x to the fourth plus 1. So now the result becomes negative x to the fourth plus 1 divided by x to the fourth plus 1 multiplied by square root of x to the fourth plus 1. That's what you'll see in options. Alright, so what did we do? We applied the rule. We are done with taking derivative in the first place, but in the following steps all involve algebra, basic math, simplification techniques. So calculus part is not hard. It's not challenging. So what challenging is the algebra within the calculus. There are many steps, many basic math, many simplification rules. So those are the challenging, the hard part. Otherwise, on grade 12 topics, calculus topics are not that hard. Okay, I'm done with that question too. So another nice and challenging question that students may have difficulties is this. It involves division and natural logarithm. It's an exercise question and it's also a mystery question. Okay, there are two methods as in the previous natural logarithm question. We have division, so we can apply the derivative of the natural logarithm first. It is derivative of the angle divided by the angle itself. You take derivative of angle by using quotient rule and simplify and equalize denominators and stuff. This is the answer, but I won't explain this. I'll explain the other, for me, the easier way. Okay, this is the last question I'll explain. Apply logarithm quotient property. So this is one of the properties you studied in grade 11. So let's say we have ln a over b. They are both variables. So you can write this natural logarithm as ln a minus ln b. So this is what this property says. I'm going to apply the same property here. Rewrite this function as ln top 1 plus e to the x minus ln but 1 minus e to the x. Now, taking derivative is easier or taking derivative of this 1 by 1 is easier. It's up to you. For me, taking derivative of this is much more easier than taking derivative of that. So now I'm going to take derivative of each 1 by 1. Derivative of ln, derivative of the inside, derivative of 1 is 0, derivative of e to the x is itself e to the x, divided by the angle. Minus, similarly, take derivative of the other ln, derivative of inside, negative e to the x, over derivative of the angle, 1 minus e to the x. Now, I see different denominators. I should get the same denominator, get the common denominator by multiplying them by each other. So, multiply this one by this, 1 minus e to the x. This one by the other one, 1 plus e to the x. So, it becomes e to the x times 1 e to the x minus e to the 2x. You have the same basis, you add exponents, remember. Minus minus makes plus e to the x plus e to the x plus x to x all over common denominator. There is like difference of two perfect squares, so you can think this as one, let's say x plus y, x minus y. So first plus second, first minus second, first plus second, first minus second. Its difference of two perfect squared can be written as x squared minus y squared, right? So I can use the same idea here. It's difference of two perfect squares, so it's square of the first one, 1 squared, minus square of the second one, e to the x squared, e to the 2x. Okay, now negative e to the 2x, positive e to the 2x will cancel each other. At the top, I am left with 2 e to the x. At the bottom, I have 1 minus e to the 2x. That's the answer. All right. So after getting the function in simplest form and taking derivative, I get this. Otherwise, you take derivative in the first place. I think the steps are much more than this, but it's up to you. So however you feel comfortable, it's your choice. Okay, I'm done solving questions about differentiation rules.